I'm Professor Darden, for those of you who are not in my section and haven't seen me yet. I will be today talking about how you can do the stuff that we need to do in 281 if you're using Xcode or a Mac, but mostly just Xcode, which is definitely Mac. But people that are using Macs that aren't using Xcode, this will be less important for you. But the things that I will be talking about too, when I talk about some of the general purpose stuff, this will apply to everyone that's programming in 281, and that's where I'm going to start, with everyone's favorite topic, makefiles. All right? Makefiles is just a beautiful situation that helps automate anything. We're going to use it to help automate, build, application creation. It helps us with some testing and some other things as well, depending on how you want to do it. You can use it to help upload your code to Kane. The makefile that we have is pretty extensive. It's probably too extensive. It's hard for most people to understand. It's hard for me to understand some of it, and I wrote it, so that's okay. You get something done right once, and then you use it again and again and again. That's kind of what's going on there. Oh, I'm not even mirrored up here. Hold on a second. That's not going to do. There we go. Whew. That's what I call resolution. Okay, for starters, let's get a copy of the makefile. And you can see that here at the GitLab server, gitlab.eecs.umich.edu. gitlab.eecs.umich.edu. So if you get the copy from here, you will have the most up-to-date version. It's going good. If you use the copy that's in Project 0, you'll probably have some errors. So please get a most up-to-date version. We're trying to move away from distributing tarballs, but that's a separate story. All right, so here's where the makefile is. That's Austin. He made our last edit. If you go to gitlab.eecs.umich.edu, the folder is EECS281. The project is makefile. It's really simple. It's the EECS281 makefile. You go here, you can see the project, you can get some information on it. If you really want to get after it, I think the easiest way is to go in here, click on the file, and then if you hit this download button, it will download this particular file. Right? And as you see here, my web browser thinks it knows more than I do. It's a text file that should be named makefile. That's it. It shouldn't be named makefile.txt, but once again, my web browser thinks it knows more than I do. So if you download this and save it as makefile.txt, that'll be your first mistake. So feel free to do this, but take off the .txt, and I'm not even sure that's going to help here because it knows it's a text file, but we'll see. I'm just going to go ahead and save this into my downloads directory, and just as I mentioned, it still thinks it knows more than me, right? Makefile.txt, so you're going to have to go in there, find it in your Finder or whatnot, and make sure that it gets named properly. I'm going to take off the .txt extension. Cancel that, I didn't get it right. txt dot, boom. And yes, I would like to remove that. So now I've got a new copy of the makefile, and I will use that in a few minutes. What I do need is a project, and in this particular case, we've got some starter code for you. So the safest way to do this with the new makefile that we just downloaded is to create your own empty project and then import the files that you're going to get off of Canvas to make this happen. So I'll get that done, and then we'll talk about the makefile. So if you're not on a Mac right now, as soon as we get done creating this project, we're going to go into how you also need to edit your makefile. So hopefully, even if you're on a PC, you will have downloaded this just like I just did. But let's create a new Xcode project here. And for me, that needs to be just a command line tool as a type of project. It's under Mac OS, it's command line tool. I can hit next, give it a name, something stunningly cool like Project 0. And then it's probably going to tell me you already have a Project 0. But that's okay. I'm going to change this to a reasonable month, right? So EECS 281, I'm going to put a new folder in there. I'm going to call that W2020. There we go. Look at that. It's just empty. And for now, I'm also going to click on Create Git Repository on my Mac. So this will give you Git support built into Xcode. We'll talk about how to make that useful later. But if you check it now, then it just does it automatically at creation time. If you don't check it now, there's a menu item that you can select later that will do all of this for you. So for now, I'm going to create it. And that's it. I've got this nice project. It gives me a main.cpp file, which I'm going to delete. But what I want to do is I want to add my Makefile to this project, so now I can get into editing it. So I'm just going to right-click on this thing here, say Add Files to Project 0. You can also do that here in your File menu, Add Files to Project 0. Both of those will get it done. Now this is a very important step for those of you that are Xcoding. There's a checkbox there. That top one, destination, copy items if needed. Whenever you're adding something to a project, make sure that that is checked. Otherwise, it will leave the file that you've just added wherever you have it. Can lead to real problems later on. It messes with source code versioning. Git doesn't handle it well. People copy projects places and lose stuff. Delete files that they didn't mean to delete. So when you add a file, say, make sure that you would like to copy items if needed. And what if needed means is, if it's not already in that directory, then I need to copy it. And that's what I just did. You saw me download the Makefile to my downloads directory. I'm going to add it to this project, but I want to copy in this directory, so I got to make sure that checkbox is checked. After that, I go to downloads. There's my Makefile. I click add, and I am good to go there. So here I have my Makefile. This is something that also gets checked. Target membership. Your IDE may look like that. You need it to look like this. If it looks like that, make it look like this. Not that, this. Click on the Makefile, and then you can come over here and say, remove that from Project 0. That target membership means when I go to build it, should I compile my Makefile? And the answer, of course, is no, because Makefiles don't compile. So uncheck that, otherwise you get these strange warnings. Your project still builds, it works, but it just gives you this nagging warning that just never goes away. And that's why, because it's trying to compile a file that shouldn't be compiled. All right, now that I've got that out of my Project 0 path, I can make it look like this, not that. All right, full screen in here so we can really get at some editing. This is a 281 Makefile. You see it here. It's about 280 lines worth of good stuff. But not all of it is something that you need to deal with. If you're at a command line, you can just type make help, and it will tell you some more about this Makefile, but only when you're in this directory. The other thing that's important is there are these to-dos in there. So all you have to do is look for a place where it says to-do. This is for all of you now, remember. Once we got the project created, this is for those of you that are also on PCs. You have this. Maybe you haven't got it added to your project because you haven't started that yet, but get this somewhere open in an editor. I'm looking for those to-dos, and there's a section at the beginning that says I have to do a begin thing. The thing that you're going to have to edit comes between these two to-dos, right? And if you read a little bit, it says I need to change what's at this identifier to match the project identifier. Every spec has a project identifier in it. You need to edit this, or the Autograder won't take your code. All right? So there's one. Change that as necessary. They don't need to change that for P0 though, do they? Or is there one for P0?
Identifier?
Yeah. Yes. There is a, okay. All right, we'll get to that in a minute too then. All right. And then the other thing that it says, you need to change this executable section here, right? These are variables that I'm setting to make my compilation work the way that I want it to work. Every project tells you what the name of the project's executable should be. So when I type the command at the command line, this is what starts my program. Here it's just called executable. That's a terrible name for an executable. In this case, we're going to change this to project 0. That's good. And then lastly, this section here wants to know where your main function is. What is the name of the file with your main function in it? You see that the first one is called project file in line 31. That's uncommented. If you want to do your own custom version, put it in 33 and uncomment 33 and comment out 31. But if you use 31, 31 tries to find some stuff for you. It looks in the directory where all of your source code is and says, hey, is there a file named project something.cpp? Because that's where the main should be. If I can't find a file named like project0.cpp, maybe if a particular program like project 1, for instance, the executable there is named puzzle. So if it can't find it in project0.cpp, it looks for a file named puzzle.cpp. Then if it can't find a file named puzzle.cpp, it looks for a file named main.cpp. So it kind of runs through those things, and in the end, if it can't find anything, it still thinks it's in main.cpp. Whether or not that exists, that's not a problem. It just helps the makefile. So my point is, for this particular to-do, you don't have to do anything in the makefile as long as you name your main file something like project 0 or puzzle.cpp. All right? So identifier, executable, and then make sure that somehow this project file points at what you want it to point at. If you want to, you can say, you know, I've got my project file is actually, you know, my main file.cpp. If you wanted to do that, why would you do that? But you can. You're allowed. All right? After that, you're in pretty good shape. What I want you to do, though, is not count on it. Go do a search for TODO, right? Because it turns out there's more than one section that we need to do things in, right? So here at the bottom, this is the one that most people get wrong as well. It's because we don't really talk a whole lot about the whole compilation procedure. This talks about file dependencies. If you get stuck in a situation where every time you type make, it doesn't do anything, it's because your dependencies are bad. If you get this here right, then you don't have to type make clean make every time you want to make something. Nothing worse than typing make clean make. It's just terrible. So we can fix that by editing things here, and you see in lines 261, 262, 263, there's some examples. So if I've got some class file, like it talks about in 261, maybe you have a puzzle class, then what I'm saying here is the file puzzle.o depends on puzzle.cpp and puzzle.h, right? That's me in this line right here. So I might take something like that and say puzzle.o depends on puzzle.cpp and puzzle.hpp, or .h, depending on how you roll, right? This tells the makefile that whenever somebody edits puzzle.hpp or puzzle.cpp, that puzzle.o needs to be recompiled. If you don't put that in there, it doesn't always know what files depend on other files. That's what we're trying to do, is fill out the dependencies here. So the same sort of thing if you've got some functions in a separate file. You can see that in line 263 now, where I've got some functions object file that needs to be made by compiling functions.cpp. But if I change my headers in functions.h, I still need to recompile that file. So this is why we have our dependencies in there. Because then you can see if I've got something separate like my main project there, here at project 0 in line 264, and your project 0 is not going to be this complicated. It's going to be much simpler. But the goal is to show you a representative thing of how this might work, right? So if I have a separate class, and if I have some separate functions, and then I still have my main in project 0.cpp, I want to say that project 0.o now depends on the things that might make changes to it. And those things that project.o cares about are project project 0.0, sorry, project 0.cpp, of course, the source file for that project. But then the interface files, the header to the class, the header to the functions, because if I make changes there, that means I've changed parameters or added or removed functions in those particular objects. And project 0 needs to know about that. So when I make changes to those .h files, that's when I also have to recompile project 0.0. So that's what you can see in those 3 lines there. Depending on how many files you add to your project, you might need to learn this stuff. You need to learn it anyways. You might need to use it. One thing that the staff really doesn't appreciate is people who have one file with one function, call it a project, right? It's terrible. If you do stick to one file, that's kind of okay, but whatever you do, don't put everything in main. They'll hate you for it. So it will also make your job 10 times harder being successful in the project. You need to figure out what's going wrong when there's timing issues, what's going wrong when there's memory issues, and if you've got one function, it is very hard to do that. Good reasons why we subdivide our code into logical sections. So if you would like to write things into a class, that example from 261 applies. If you don't want to go the class route, but you just have some external functions, that line from 262 applies, and you can see how they both contribute to what's going on in 263. So that's what you need to do every time you write a new Makefile from 281 is you need to fill out these sections, the one at the top, and then this one here at the bottom, right? You see this? The first to do has to be up here before things get called later in the Makefile, and then I can keep all of my dependencies right here. It's right 10 lines from the end of the file, and this is where you can put them in there. If you're not so hot on how to make these dependencies, write the files, and every time you find yourself typing make, clean, make, then go in there and just type that at the command line, and it will tell you what the dependencies are. You can copy that output and paste it right into this file. It's wonderful. Learn how to use a Makefile. It's a tool. It's one of your tools. Might control a good section of your life this semester. So, learn something. We're not teaching it. Shoot. Yep. Project file. Okay, the one at the top. So the project file is the file that is in my project that has my main function in it, right? This is the one that's looking for a project's main. So as my current project stands, the name of my main function is here in this file main.cpp. And so because that's a thing that happens quite commonly, you see here that it looks for project file as either something named project blah.cpp or executable.cpp in this case, which would be project 0.cpp as well. Or if it doesn't find either one of those, it would still say, oh wait, there's a main.cpp, I will use that. So you don't have to do much there if you name your file with main in it reasonably, right? Just call it project 0, or if you're working in the puzzle project, call it puzzle.cpp. Or if Xcode creates a main.cpp for you, just leave it there. That also works. What other Makefile questions do we have burning? Shoot. 261, 262, 263, yeah. So these are dependencies when I've got files in my project, right? This lets Make know when it wants to compile, for instance, class. There's a class that I have in my project in this example. The class is divided into a .cpp file and a .h file. The header allows other modules that are going to use the class to interface with the code that gets created in the CPP file. So when I compile that, the compiler knows for sure that class.o is dependent upon class.cpp. So if you go simply, that's going to work. What it doesn't know is that class.o also depends on class.h, because it can't know that. It's just stuff that's in the code. So since I know it because I wrote the code, I put those things up there. Because I might call my header file something else. I might have one header file that declares all of my classes, and that would be a bad thing, but it would be legal. And I just want to let it know that in order to compile class.o, anytime changes happen in class.cpp or class.h, then I need to make a new compilation of class.o. Yes, absolutely. So any, you don't have your header files depend on other files. Yes, but anything basically that would lead to a change, right? So if you make an edit, so for instance, if class.h depended on some other file called wall.h, right? Changes that I would make in wall.h would get included into class.h, would then get included into class.cpp, and then if I made changes that were important enough in wall.h, class.o wouldn't know that it needed to be recompiled unless I said that class.o was dependent upon class.cpp and class.h and wall.h, right? Since there's no build of class.h, I wouldn't say that class.h depends on wall.h because class.h is not being built. You see what I mean? So if I wanted to do that because class.h also depended on wall.h, I would just have to add wall.h up there as well. Yeah. You good with what I was saying there? Right? Because the second one is just like if you're not into classes and you just want to put some utility functions in it, it's the same sort of thing. It's going to create an object file from source code and a header file, and then the main project file is going to need to be having access to those headers. And so now if I make a change to a function signature in functions.h, project.o would probably be using that function and need to recompile because of it. Or project0.cpp would, sorry. No, the order of the dependencies, as long as they're on the left side of the, this side of the colon, they're good. It's really recursive.
If we made some mistakes doing all these dependencies, can we always use makeclean?
Yeah, makeclean will always just delete all of your object files and then rebuild everything. Yep. There was somewhere over here. Sure. But that's the same as typing make clean every time, because then every time something gets changed, everything gets built. So yeah, if you want to do that, rather than trying to maintain the list of everything, just type make clean every time. That is an executable, right? And test thing is an executable in line 260. See, there's no .o after it. So that one is like maybe I was writing some tester file, and the tester file has its own separate main, separate from my project 0 main. And it needs the compiled class.o and functions.o because it's trying to test the things that I wrote to use in the main project. So that's just a separate thing. And so that's saying the executable there needs to know about its own source code and then the other things that are being tested.
Do we need to kind of like changing the tested thing as there will be functions like executable or?
Sorry, I missed that question. Say it again.
So on the tool, we kind of like put the main function's name and then like as like executable or something on purpose to do this.
Mm-hmm.
So we kind of like do the testing, like the tested thing, like assume this is the name of our main function for doing the test. Do I need to change that part to test the thing?
Oh, yeah, that's part of the other magic that goes on in this file. If I have a file, for instance, named testthing.cpp, this makefile looks at it and says, hey, that starts with test. Hey, it ends with .cpp. I think I can make an executable just for that. So it will make a separate executable named testthing just because I have a file in there named testthing.cpp, because it will be expecting to find a main function. So that's a side gotcha. Don't name any of your files test anything.cpp unless they really are tests that you're doing sort of like unit tests, integration tests on the side. They're not for turn-in code. No, you don't need to change anything at the top, right? That's what it is if it finds your executable where it thinks it should from the project file, then it ignores the other ones and allows test thing to work just fine. So you can write your own separate file, test my class.cpp, test my maze.cpp, test my output.cpp, and all of those get built into their own separate executables that are not the turn-in executable. And they don't even get uploaded to the Autograder when you send it. It tries to be really smart. Shoot. Make is pretty strong, yeah. Make can handle that. Yeah, it will work. .263, why does it contain functions.cpp? Because of the separation between implementation and definition, right, or declaration, right? The .h files are used to declare what's going on, and the .cpp files are used to implement what's going on. So after things get compiled, they get turned into object files, which where we get functions.o or functions or class.o. And then the linker comes along and says, here's a function, I'm going to turn this all into an executable by pulling it together. So what happens is, I don't need to recompile my main just because I recompiled some functions. They just need to be relinked, and make will do that. But it won't compile it if it doesn't need to. However, if I make a change that's like, I'm changing a function signature, that's me changing something in functions.h. So then how Project Zero is working with that is it needs to know that there was a change. So we don't care about changes in the implementation because the interface hasn't changed. Without the change of the interface, the .h file, then we don't need to do a recompile of the project, right? The .o file doesn't need to be changed, it just needs to be relinked. That's the subtle part that is really hard to pick up as you're learning how to do C++ compilation.
Okay, so if I have all my dependencies set up properly, I only have to make the executable once, and then whenever I make changes to like the files, functions, tweaking it,
Yep.
it'll figure it out.
It'll do whatever it needs to do. Right, you can just type make and it will do the minimum amount of work necessary to give you the most up-to-date.
And then once I do the changes, I can just run the same executable before running it.
No, you still have to type make. Anytime you make changes, you still have to type make. But if you don't get your dependencies in there properly, when you type make, it might not know that something depends on something else, and so it won't compile things properly. It might say, there's nothing left to do for make, because it thinks of your executable as this file, and then it thinks of this other source code as some file that it doesn't care about. And so it looks at the executable and says, well, this is the newest thing that I care about. I'm not going to recompile. But if you say, now this executable depends on this source file, and this source file is newer than my executable, then I have to recompile so that my executable is at least as new as any of the source code that it depends on. I know, we're deep into it. And you're going to do this in lab. But in the end, still, most people don't get this right. So it never hurts to talk more about make. There's also a class that I used to teach, 201. It's a great class. It's a 1-credit class. Happens on Fridays. You should check that out. They will talk more about make and teach you that stuff there as well. So now I've got my make file ready to go. So hopefully you've got yours edited, PC or Mac, and ready to go. What I'm going to do to finish this particular project to get it started so I can hand things over to Dr. P is go back to my browser. Which browser? There it is. Right, we got the make file here, and if you go over to Canvas, right? I know it's ridiculously tiny. Excellent. So this has been updated. I'm going to refresh my screen here because he just made an update. Make sure that's good. But you can see here I'm on Canvas, the main Canvas page for this course. If you go to Files, and then I'm over here in the Project section. Underneath there, I've got Project Zero. And then here are the 2 things that you can download to get yourself starter code files for this. I'm going to go ahead and download the Mac Unix version because I'm on a Mac. If you're on a Mac or using Unix, you need to do this. If you are doing all of your work exclusively in the Windows subsystem for Linux, then you probably still need to use this version as well, even though you're on Windows. See him later. So those of you that are okay, yeah. I'm just gonna download this Project Zero starter, and you can do that as well. I'll click on this and it will show it to me over here. And then all I really want to do is find my Xcode and say, let's add some files here. So add more files. And now the files that I want to add are still in downloads. It's in this starter file directory. And all I really need from this is this. He said he just updated the Makefile, but since I don't want to overwrite the Makefile I have, I'm going to deselect that one. If you want to grab this whole thing like that, you can. So there it is. I'm just overwriting it, Dave, doing it. It's got the project ID in it. That's good. Copy items if necessary. It might complain. It didn't complain. There we go. So now my project has 2 Makefiles. There's the one that I don't need, right? Because you can see the project identifier is EECS281, EECS281, EECS281. So this one, they're the same one. Look at me messing things up. Oh, you didn't change the project identifier in it, though, did you?
No, I didn't.
Okay. All right. Saved. Okay. So in any case, I think that's the new one there. Yeah, I'll delete that one. It's not as good as the other one. Yeah, delete it. Good. He's going to fix that, so if you want to re-download it in a second with the proper project identifier in it, he's going to put that in there and upload a new copy. So there's what my project looks like when I'm ready to go in Xcode. I've got a project 0.cpp file, and I've got this unnecessary main.cpp file. If you keep that around, you're going to get this kind of error all the time, right? It's a linker error. It's going to complain about things that don't work, right? And there it is. Duplicate symbol for architecture. And you see it right there. Right in that second gray rectangle, it says duplicate symbol main. That should be telling you right now, it has compiled 2 separate files with a main function in them, and it's trying to make them all into one project. That's a big no-no. So it's saying, no, that doesn't work, and I'm going to fix that by getting rid of the problem file, right? I'm just going to go back to main here, it's the one I don't care about, and delete that thing. I move that to trash. Now as I compile, build succeeds. So that should get you to a place where Dr. P is going to take over. He's going to lead in with a little bit of PC stuff, and then he's going to be doing some editing things that all of you need to be doing, whether you're on PC or Mac. You ready? Oh, he's still uploading the new version. All right. So now it looks like
It should say 241.
date modified 241. That's hot and fresh. Those bits are still steaming. Sure. Yeah, that's good. What's that?
I don't know if
No, it's off.
Okay.
You can turn it on though if you want to unmute it.
Which one is it?
The one on the far left.
Oh, okay. All right.
Check.
All right, so hopefully the mic here is working without the, whoa. Oh, that one, huh? Oh, that one's worse.
Not this one. That one. Yeah, it's definitely that one.
That's the hot one. Well, the problem is my screen's in there. All right. Let's see, I think it's working. All right. So now we just got to change the projector over here. All right, there we go. So we've got the updated files. Sorry I didn't have those updated beforehand, but it'll make it a little bit easier now. So what I'm going to show you how to do is we're going to start with how to get some files into Visual Studio. Then we're going to do some coding that's needed for the Project Zero, and the coding part is going to be for everybody. So if you don't have a PC, you can ignore me for a few minutes. I'll get your attention again when we're going back to stuff that everyone needs. All right, so over in Visual Studio, we've got to create a project. So I'm going to say create a new project, and mine is going to be selected, the type I've used most recently. Yours, it's going to be a little bit different with like every version of Visual Studio, whether it's 2017 or 19, whether it's enterprise or community, you might have to make slightly different choices here. So we're going to have, part of our session today is going to be having staff help you if this didn't work. So we're going to get to that in a while. So what's been working for me with, well, let's see what version I have. I've got Visual Studio 2017 Community is what I'm using right now. Okay, so this hopefully will work. So I'm going to say I want to create a new project. My most recent type is Windows Desktop Wizard. I'm going to change, this is something that Visual Studio, it used to default to the same folder once you change it, and now every time I start Visual Studio, I have to change where I want my files to go. So I want mine in Documents, Visual Studio 2017, Projects is going to be my folder to put it in. Then I'll just change the name of the project from Project 1 to Project 0. Apparently it's just like projects named Project 1. And then I want to make sure I've got this create directory for solution. I want that checked. If you don't check that, different versions do slightly different things and you'll end up with a little bit of confusion there. Sometimes it'll throw everything, every single project into one folder, which is a lot more painful. So we want to check that box, say OK, and we should get, there we go. So now we got a new screen. I want to deselect precompiled and security, and then I want to check empty project. Sometimes when you check empty project, it disables changing the others. So I want to turn off everything except empty project, turn that on, and then say OK. All right, so completing operation. So now I've got a new, you can see up here, I've got a new Project 0. There's nothing in it. If you've created a project that has like a main.cpp or something.cpp, it already exists. If it's got a standard AFX.h.cpp that already exists, it's the wrong type of project. So you want a completely empty project. Now for Project 1, you're probably going to start this way and you're going to have to start with your own source code files. For Project 0, there's already code available. So I'm going to go over to Canvas and I'm going to get my Project 0 starter files for Windows. I'll say, okay, let's download that. And I'll just open this up. Oh, zip. Yeah, okay. So I've got that zipped. I'm going to open it up. And then I've got 4 files in there. So I want to say extract. I guess I have to select everything first. Okay, now extract. Okay, it doesn't want to extract them. Okay, that's all right. We can deal with this. So what I'm going to do is just hit Control-A, Control-C. Control-A is select everything. Control-C is copy. And then I'm going to go over to my documents, Visual Studio 2017, projects, and find my Project 0 folder. And notice there's another Project 0 folder inside of it. We want to put the files in the inner folder. So I'm going to put them there. And there's a few files here already that Visual Studio's created. And then I can just say Control-V to paste those files there. Okay, so I've got my Makefile, CPP, I've got my sample files for input, and we're ready to go. So we can go back to Visual Studio. And now I'm going to say source files, add existing items, because they already exist. Now, if you say existing items and what you want to add is not immediately available, you put the files in the wrong folder. So you don't want to go browsing over to like your downloads folder and add them there, because then your project is over here in your project folder and your source code files are over there in your download folder, and that's going to make it hard to upload to the Autograder. So I want to make sure when I say add existing item, the thing that I want, like my source code, is already in the default folder that comes up. So I'm going to add project 0 here. And then I've got to click again to open that file up. And okay, so it says to do, add the project identifier. So it's actually in the header file. I'm going to add the header file. I'm going to put that under resource files. I'm going to right click resource files and say add existing. And I'll add the Makefile as a resource. It's not source code, it's not a header, but it's part of my project. So I'll add it as a resource, and then I can double click that to open it up. And if we scroll down, we've got the same to-dos that were in the Mac version, but now we've got the identifier somewhere where we can double click it, Control C to copy it, and then I'll go back to my source code, and then I'll add my project identifier here. I'll just paste that in. Okay, so I've got my project identifier. Now, we're now to the point where we need everybody, Mac people included. So now that we've got our project identifier in our source code file, what we've got to do is go and modify the source code. We're going to show you some things that you haven't done before. And so I'm going to, let's see, I'll go, I do these things sometimes without thinking. Alt-Shift-Enter on Visual Studio will make the editor full screen. So if you find yourself wanting more real estate for editing, it's Alt-Shift-Enter opens up the editor in full screen. So we got our first to-do taken care of. We got the project identifier. Next to-do says, finish this function. Now, Marcus, I'm going to apologize. One thing I forgot that we talked about last year, but we didn't do, was modify this. It returns a string. Okay, so this function is a great idea for your project 1, but your project 1 is going to be more complex. So if you use this function for project 1, what I would do is instead of having it return a string, make a structure and return a structure of that type. And we talked about this last semester, and we were going to do it, and then we forgot to do it. So I'll talk about it, and then you can hopefully remember this for project 1. So project 0 only has one option, so we just return it as a string. Your project 1 is going to have to do the same sort of stuff, but it's going to be more complicated. So instead of trying to return like 5 different things in a string, make a structure, say that my function getMode is going to return a structure, declare a variable of that structure type, and return that structure type when you're done. Now, let's look at what we have to do to get this working for project 0, though. So it says, look for individual to-do comments internally, process the command line. The only thing we need to return is the mode when the user specifies the -m or -- mode option. So, learning how things work in Unix and command line for Windows and Mac, etc. When you run a program, sometimes you want to tell that program on the command line certain options that you would like it to do. For instance, if I'm in my Unix shell and if I do ls, it lists the files. If I do ls space -l, it gives me a long or a detailed list of the files. So what we're going to learn is how to make your program respond to those command line options the same way existing programs do. And we're going to do that with something called getOpt. So back in our source code, what do we have to do? So it says there's individual comments below. So first to do, fill in 2 lines for the mode, M, and help, H, options. Many command line options have a long form and a short form. So we're going to make ours work with either one. whether I do, like, I don't even remember. I do ls-l so often. Is there ls minus minus long? Nope, it's not a real option. So bad example. So some things have short options, some have long, some have both. So we want to work with both. So what we have to do here is we've got to fill in, before this existing line, I've got to add a new line of code here. So hit enter there, and we need a new line of code, and it's going to be just like the one below it, except different stuff inside. So I'm going to have curly braces, and I need. First thing we need is going to be the long version of the option in double quote marks. So I'm going to put double quote mode, double quote. Okay, so mode is the name of the option. That's the long name. Then the next one that comes after this is whether this option has a required argument or not. So how do you decide that? By reading the project spec and seeing what it does. So this one, mode, is going to be followed on the command line by another word. So this one has what's called required underscore argument. Now, if yours doesn't help you with the prompting of, hey, there's something called required argument, that's okay. We're going to get to that when we help you individually. There's stuff that you have to do to get Visual Studio ready for GetOpt that is not there by default. Every IDE, it turns out, every single IDE has some shortcoming. Visual Studio's shortcoming is that GetOpt does not come with the compiler. Xcode's shortcoming is that it doesn't deal with the command line very well. Every other IDE has that same problem. There's basically, Visual Studio doesn't have GetOpt at all, but it deals with the command line really well once you fix that problem. Every other IDE has GetOpt long, but it doesn't deal with the command line well. So everybody's got a little bit of problem here. So if it doesn't prompt you with, hey, there's something called required argument, we'll get that fixed. So required argument, then the next thing we're going to put after that is, and I'm just going to modify mine to line up there a little bit better. Okay, the next thing after that is always going to be null pointer. There's a feature of GetOpt that we're not going to use, so we put a null pointer here to say I'm not using that. And then the last thing we put is inside of single quotes, we put the short form of the option. So this will be single quote M, single quote. And then I've got to add a comma after the closing curly brace. Because if you notice what we're doing here, go back to the top here, I said make me something of type option. Where did it come from? It came from the include file. Create me of something of type option. I'm going to call it long options is my name for it. And the square bracket says I'm going to create an array of those option structures. So I'm going to create an array of those option structures, and every line here is one entry that's going to go into that array of structures. So we added one line for the mode, and we're going to add one more for help. So we just hit enter there, another set of curly braces. Oh, Visual Studio decided I'm indenting wrong. Too bad. Okay, so we'll put double quote help. So that's the long version of the option. And then help does not have an argument that follows it. So you've got to get your terminology consistent here. Mode and help are options. Mode has an argument that goes with it. Help has no argument that goes with it. So we type in no underscore argument. So mode has a required argument. Help has no argument. Help is kind of like when I did ls-l over here. I didn't say ls-l space word. I said just ls-l, and it lists everything long. So help has no argument. I'm going to put a comma, and I'll put some spaces to line this up. Null pointer is always going to be there for a feature we don't use. And then single quote H, single quote. And then we need a comma. After that closing curly brace, we need a comma because we're in the middle of an array of stuff. There's the first element of the first structure that includes mode. The second structure includes help. And then the third structure that was already there, we're going to leave alone, but it's got to be there. This last one is like a \0 for a character string. Remember in 280, if you've got a character string, it ends with a \0 to tell the runtime you've reached the end. Well, if you leave this one off, you might get a runtime error where your program starts looking through those options and doesn't know it's at the end. If it doesn't know it's at the end, it could keep going and looking at invalid places in memory. So you've got to have that last one. That last one with all the null pointers and zeros is basically saying, this is the last one, don't look any further. All right, so we took care of our first big to-do there. The second to-do is right just a few lines down here. It says to-do, fill in the double quotes to match the mode and help options. So between double quotes here, we've got to put, basically, we've got to repeat the short versions of the arguments, of the options that we actually put in. So we've got to put M and H, and we got to put one more thing in here. Between them, well, I shouldn't say between, after the M. Because M is followed by a required argument, we've got to say M:\h. The colon says there's a required argument here after M. Why do we have to do this twice? Why do we have to specify it twice? Because this piece of technology is old. It's existed for on the order of 40 years now, and it wasn't perfect to begin with, but nobody ever changed it because it would make stuff in the past incompatible. So this is a little bit of a painful thing you have to get used to, but once you get it working for Project 0 and Project 1, your next couple projects are going to be easy. You're just going to copy this, modify it, and you'll have your next project working. The thing to be careful of is when you copy this and modify it, remember to modify everything. I've seen people on Project 1, they're like, ooh, I'll change mode to stack and I'm done. And they forget to change the M to an S. So when you do modify this, just make sure you're consistent and every time you fix something, change it consistently. Okay, so we've got the M:\h filled in. Whoops. We got the M:\h filled in, and then down below here, there's some more code that already exists. There's no to-dos here, but let's talk about what it is doing. So it says, I'm going to run through a while loop, and if you notice the parentheses here, there's where that inner set of parentheses ends. This is a confusing statement, but it's the easiest way to get it done in one line. So what it's doing is it's calling getOptLong with a bunch of parameters. getOptLong is returning something that's getting stored into the variable named choice. And then it checks if what was stored into choice is not equal to -1. So this is saying basically while getOptLong returns something that's not -1. It returns -1 when it's done. So we want to keep going while it's not returning -1. While it's not returning -1, it's finding things on the command line that it needs to deal with. So then, inside of there, we say switch based on the choice. What is choice? Wait, got to look up here. Choice is a variable of type integer. It's an integer because that's what getOptLong returns, is type int. So we made this variable choice for you. It's what gets set equal to getOptLong, but then we say switch on choice, and then our case statements all look like characters. For it to compile on every version of GCC and G++ and Mac and PC, you want that variable choice to be an int, but we treat it as if it's a character. The thing to remember is in C++ and C, it tastes like chicken. If it's an integer, you can treat it like it's an integer. So there's lots of things you can treat as if they are integers. They all taste like integers. So we've got an integer, we can treat it as if it's a character to make things easy to type. So what I've got here is I've got a switch statement and I've got a case for everything that can appear on the command line. So I've got a case for the help, it prints help and exits. I've got a case for M, and it deals with getting some stuff done, and then it's got a default just in case it runs into a letter that it didn't know. Like if you accidentally put a N on the command line instead of M, it would say, oh, I don't know what that option N is. It's not anything I've got a case statement for. So what does M do? It says set mode equal to optarg. Wait a minute, what are those? Okay, mode is something I created up here, is a string. Optarg is something that we got because we included, way up at the top here, because we included getopt.h, there was a bunch of things that were made available to us. One of them is that function getopt_long. Another one is this variable type option is a type of struct. And the other thing that it made available to us is optarg. Optarg, if I mouse over this, it should say it's a character pointer. So optarg is a character pointer. It is pointing to the thing that followed the option mode. So whether the user typed -m space or --mode space, optarg is a pointer to the word that follows it. So what I'm saying here is, hey, take that char pointer and copy its contents into my string variable called mode. So let's make a copy of that character pointer, store it in a string object. Now I don't have to worry about length or anything. It goes into the string object is the right size, everything's good. And I can do things like I can do comparisons of equal, equal, and not equal because now I'm dealing with a string, not a char pointer. If I've got a string, I can do equal, equal, and not equal. So this here is some error checking to say, hey, the thing that follows mode must be either resize, reserve, or no size. If it's not one of those, that's an error, exit the program. Then it says the mode has been specified is just a Boolean variable. And then after the while loop is done, notice there's some more error checking to say, hey, if I process the command line and I never saw a mode on the command line, that's an error. This program only works if they specify a mode or if they ask it to display help, which would have exited the program. So if we get out of the loop and there's no mode specified, that's an error because there has to be a mode on the command line. This mode must be on the command line has nothing to do with required argument. Required argument says --mode has another word that follows it. It has a required argument following it. If you want to say this thing must appear on the command line, you've got to write some code to do that. You've got to write some code that says, hey, if there was never a mode specified on the command line, that's an error. Getopt_long can't do that for you. But what getopt_long can do is impose the requirement that if someone types the option -m or ---- mode, they must type another word after it. Okay, so I don't see any hands yet. If you've got questions, get them up there. I'll deal with it. Yes?
What if the required argument would have a dash in the front? Would it be considered?
That's not a valid argument. So arguments must be things that do not start with a minus sign. And that's sort of just a general requirement of how this system works is arguments are things that don't start with a dash. All right? Yes, so next, yeah. Depending on what? Sorry?
Why doesn't help have an argument? The mode.
Oh, okay. So her question is, why doesn't help have an argument? Because that's how things work in Unix. So let me give you an example. If I do like G++ ---- help, I don't have to type anything else. It gives me help on what G++ can do. So that's just generally how help works. Help generally does not have an argument. Sometimes it does though, but ours it doesn't. Ours help will always have no argument. So either someone is asking for help or they're running the program. Okay, any other questions? Yes? Yep. Well, if you don't understand that, that would be maybe, you know, it's something that you've used in 280, or maybe it's something you learned in 280 but didn't use it very much. So you probably learned that it exists but didn't use it much or at all. So what the switch statement does is switch is saying, I have a variable that is of an enumerable type. Enumerable meaning it's like an integer. So you cannot switch on a double variable because it has effectively almost an infinite number of possibilities. So you can switch on integers, you can switch on characters, and you can switch on something else we're going to teach you about later on. So you say, I want to switch on this variable, and then you have a case statement for every possibility that you want to consider. So there's a case statement for H, there's a case statement for M, and then if you want to have a catch-all for anything I didn't specify, that's default, and default always comes last. The other thing that's important about these is that every case statement should either end with an exit, which means the whole program is done. It should end with a break. The break prevents it from falling into the next case below it, and default always must be last. But other than that, you know, use it, and you might find a place in a project where switch is useful, and you'll get more practice with it. You know, look it up on c++.com if you need more help, or come to office hours and ask me more about it. Yeah. Right, if you don't have a break statement, it'll just keep going. And that's nice if you want to do, like, let's say I'm getting a yes or no from the user. And I can say things like case, lowercase y, next line, case, uppercase y, and then code to deal with either one of them. And that's why it falls through, because there's no break statement. Yes, over here. So for line 49, you mean?
Yeah, what would the get op long return?
What get op long returns is the first letter of what it saw on the command line. So get op long, if I type, like over here, when I typed -- help, get op long would have returned the letter H, because it's the first thing that's not a dash. Yes? So there's in Canvas files, resources, there's a set of Visual Studio files, so there's a folder called Visual Studio Files, and there's a file called Installing and Using Visual Studio. So the file is in the folder, and the PDF tells you where to put it. Okay, yes? Excuse me, what?
Why are we matching the mode and help options? What does that mean?
Okay. So we're matching the mode and help options because if someone runs our program with help, we want to display help and we're done. If they run it with -m or -- mode, we want to remember what mode they specified. So it's a way to tell a program on the command line how it should be running. So sometimes you want to tell a program up front, this is how you're going to run. Rather than starting the program and then answering a question about how to run it, you tell it how to run on the command line. Like ls. ls, I just do, if I do ls, it doesn't ask me, do you want a long or a short list? It just lists the files. And if I do ls-l, it gives me a detailed list. So the command line is a way of telling a program how to run without having it have to stop and wait for more input. Does that answer your question?
Yeah.
Okay.
Also, so mode and help are just like really common things you see in Makefile, but are there like...
They're not in Makefiles. Help is very common. Many Unix programs have help. The other options will be specific to the project. So like Project 1 will have help, but it'll have like half a dozen other options besides help.
Okay, so mode is just an example.
Mode is just something we called it for this example. So like for for project 1, there will be different options, and some of them will have required arguments and some will have no arguments. And it'll be obvious from the project spec which ones have arguments and which ones don't, and what's the long form and short form. Okay, yes?
You said that get up long, like just read the first letter. What if you have two options that start with the same letter?
Our projects will never do that to you because that would get confusing. So if you have, really what, it doesn't actually read the first letter. It parses it sufficiently to determine what's going on. So like if you had options called like, what? Like medium, yeah. So let's say we had a function, we had an option called mode and an option called median. It would read mode or median, but then what we would have to do is we would have to make sure that the short form was not M for both of them. So it'll read the whole thing and determine which one it really is, but then it'll return. If it matches something, it'll return the first letter. Okay, yes?
Maybe this doesn't matter, but if you have like a program that just has, if it just has help and like there's nothing else that starts with H, and you get
Okay, let's find out. G++ minus minus hello. It says, hey, I don't know that one. Did you mean help? So I don't think that's built into the get opt long, but it's probably built into G++. So they looked for how many letters match. Okay, we're getting a little bogged down in this. We're going to talk a little bit more about this in lab also. So let's get back to what else we have to do. So let's look at our to-dos. So what I want to do is I want to make one of these options work. I want to test if they do work. So what I'm going to do is I'm going to build my program. Okay, it says, oh no, did I not do that? It's possible. It says I don't have a get opt long. Well, apparently, I did not do what it said because I got a new computer recently. Apparently, I haven't put get opt long in place. So I guess we're going to do that together, and then you'll get to see how it goes. All right, so I need my Windows button here. All right, what I need is start button. I need, actually, Windows X is better. Windows X brings up this menu. And what I need is I need the Windows PowerShell admin. Okay, yep, do you trust me? Yep, I trust myself. Okay, now I need another thing. I got to make sure that I've got a copy of that file. Okay, I do have a copy of getopt.h, and it's in my download folder. So if I didn't have that, what I'd do is I'd go over to Canvas, go to my files. So this is Visual Studio specific. Sorry, we got to get this working. Files, resources, Visual Studio files. I need getopt.h. I'm going to download that, save it. And unfortunately, your browser can't put it where it belongs. So I'm going to put it in my downloads folder, and I'll just overwrite the one I've got. Okay, so I've got a getopt.h in my download folder. All right, back to my PowerShell. So now what I've got to do is I've got to find the right folder to put it in. So I'm going to cd /pro, and I hit tab. And it's going to complete it for me. This is what saves a lot of typing. I actually want program files x86, and I'm just going to pause. I'm going to do it one step at a time. I'm going to change that directory, and I'll pull up a directory, and there should be a Microsoft Visual Studio in here. Okay, so change directory. MIC, no, not KEY, MIC, oh gosh, this red on black is killing me. I'm colorblind. Okay, Microsoft Visual Studio, there we go. Okay, what do we got in here? We got 2017 and 2019. So I said I'm on 2017 community, so we'll go to 2017. And then I need to be in the community folder. And then, we got lots of options. I need to be in the Visual C folder. Tools. MSVC, and then there's going to be a version number here. Everybody might have a different version number. That's okay. Change to that version number. And then I want to go to the include folder. And I just keep doing this by just, without even thinking. I type IN, I hit tab, it finishes it for me. If you don't type anything, if you type CD and just hit tab, it'll just start going through them in alphabetical order, or actually whatever order they're listed in. Okay, so CD include, and if I pull up a directory here, there should be a lot of files in there. That tells me I'm in the right place. So now what I'm going to do is I'm going to say copy, and now here's where you got to know your own folder names, /users, and then mine should be Paoletti, download, and then getopt. No, I don't want getopt.c, I want getopt.h, and I want to copy it. If it doesn't say anything, it probably copied it. So I can say dir get star, and there it is. I've got getopt.h is now part of my compiler include folder. So now if I go back to Visual Studio here, oh, I know what the problem is. I forgot one step. Getopt.c. I actually had done this already. I forgot. I had done this already. Mine was fine. What I forgot is the thing that you have to do in Visual Studio as part of every project is getopt.c. So the putting the getopt.h in your compiler folder you have to do once. The other thing you have to do is every time you build a project, go back to Canvas here, the getopt.c, I need to put a copy of this file in every project I create, and I forgot to do that. So let's download that, save the file, and this time I'm going to put it right where I want it. I want it to go in my documents, Visual Studio 2017, projects, Project 0, where'd you go? Project 0, and then the Project 0 folder inside of that, and then save. Okay, now we got to go back to Visual Studio, and we got to say source files, add existing, getopt.c. So this one we're going to make it part of our project, and now I should be able to recompile. And there we go. So we successfully compiled. And if you're having trouble getting that working, we're going to help you in a little bit. We're going to break out. When we get done with all of the other stuff, we're going to stop and we're going to have all of our IAs and GSIs, plus me and Professor Darden, help you with Visual Studio and Xcode. So now, if I run the program, it says, error, no mode specified. I have code that says you must have a mode on the command line, but I forgot to tell Visual Studio, hey, when you run my program, this is the mode I want you to put on the command line. So I'm going to go here and I'm going to right-click the Project 0 that's in bold. So you right-click that one and we say Properties. We're going to change to Debugging, and right here, Command Arguments. We don't have to put like /project 0. We don't have to specify the executable name. We just have to specify everything else that's supposed to go on the command line, like -m space, let's just pick one, resize. Okay, so -m resize, hit OK, and now when I run it, it says, you've got no data, therefore there's no statistics. So the problem here was that it didn't have any input. And the other problem is the function's not done. So I told it run with the resize option, but if we look further down in the code here, to do, oh, it's actually, I guessed right. The very first function, we've got a to do this. So we're back to everyone, so it's not Visual Studio stuff anymore. So everybody, what we're going to do is we're going to write this function together. Again, Project 0 is meant to really get you in touch with the Autograder. It's not meant to be a hard coding assignment, but it will teach you a few things. So it says we're going to write this function. It should do the following. It should read the size of the data to be read. It says use type size t. So I've got to create a variable of that type. I've got to read it in. Then it says use data.resize to set the current size of the vector. And then it says use a for loop to read in the specified number of values, storing them into the vector using a subscript. And then the last thing it says is to do, delete the following line of code when you write this function. It's only here so that the file compiles. Okay, so let's get rid of that. We can get rid of that, delete this code, and we're going to do what it says. So step one, we've got to create a variable of type size underscore t, and I'll just call it size. Whoops, if I could type correctly. Okay, call that size. And then I've got to finish step one is read it in. So I go, where do I read it in from? Unless we say otherwise in 281, we're reading from CN, everything. So we're going to read from CN, and it's going to go into the variable size. All right, so step one is done. And we could even, if we want to be really pedantic, step one is there. Step two. Okay, step two says use data.resize. So data is the name of a vector. .resize is the name of a member function. So I'm going to say data.resize. And when I put in my parenthesis, it's going to tell me, hey, this function expects you to give it something. It calls it underscore new size, but I have to give it a variable that exists of mine. I give it size. So I'm saying, hey, empty vector, make yourself big enough for the number of values I expect to put in there. Okay, so step two's done. Step three. Step three says use a for loop, read the specified number of values, and we're going to store them into the vector using a subscript. Okay, so I need a for loop. For. Now, to prevent us from having trouble with the compiler complaining about wrong types of variables, we want to be consistent. The resize function expects something of size t, therefore I made my variable size of type size t. Because I'm going to have to run a loop and compare my loop variable to size, I'm going to make my loop variable the same type. If I make my loop variable a different type, like if I make my loop variable an int, then the compiler will complain that I'm comparing an integer to a size t. And we don't want that. So I'm going to say size underscore t, I equals 0, I is less than size, plus I. Whoops, that's I. All right, so there's my for loop. What am I going to do inside of it? When I write curly braces, I immediately comment them. It's a little pedantic, and when you've got one level of curly braces, it's not too bad, but I've seen people in offstars, they've got 7 levels of curly braces, and one of them doesn't match, and they don't know which one. If you commented all of them, as soon as you create them, you'll know which one doesn't match. All right, so inside of here, we got to do step 3, which says we got to run the for loop, we've got to store, we've got to read a value, and I've got to store it into the vector using a subscript. Because my vector, we got to talk a little bit about how vectors work. Back in main, somebody created a vector called data, and it was empty. It was size 0. It was not just size 0. Behind the scenes, it had a capacity of 0, meaning its block of dynamic memory is of size 0 also. When I did resize, it changed both of them. It said, if the first number that the user types in is 10, and I say, hey, data vector, resize to 10, that data vector goes and allocates a block of dynamic memory of size 10. It sets the current capacity to 10, and it sets the current size to 10, meaning, hey, there are 10 values that exist, that's the capacity, and you can access all 10 of them, that's the size. So since they all exist, what I'm going to do is I'm just going to read from CN into data sub I. So I'm going to read directly into data sub I, and that's it. I'm done with step 3. So I've got my for loop. Every time through the for loop, I read a value. I store it directly into the array because those locations exist, because the capacity is big enough, and they are accessible because the size is big enough. And we're going to deal with a couple different ways to read here. There's 3 different functions for reading depending on the mode on the command line. All right, so now let's try compiling this and running it again. Okay, this program doesn't prompt you for input. It's waiting for me to type input. Okay, let's type input. It's expecting a number, I'll say like 4, okay? Now it's gonna read, what is vector data? It's a vector of doubles, okay? So I'll just type some doubles in. 12.1, 10.0, 8.4, what? Okay, just 1 second, and 2.2, and then it runs. Okay, question, where are we?
So for resize, so when you use it, does it default initialize all the values that are added?
Yes, it does. Good question. So when you say resize this vector, every one of those elements gets a default value of 0.0 for a double. If they were integers, they'd be 0. If it was a vector of Booleans, they would be false, etc. Yeah. Yes.
So here's this repeat again, like before doing other steps, how to work like this. Right now, when I'm running on Xcode, it's still kind of like sitting there with messages.
Oh, so it's complaining about on Xcode or Visual Studio? Okay, what's it saying? Oh, okay, that's because we haven't told you on a Mac how to specify the command line arguments. We're going to do that in a few minutes. So if you can't run yet on a Mac, that's okay. You don't know how to specify the command line. It's different from a Visual Studio. Yes? We'll get to that in a little bit. So we'll let Professor Darden run through how to do this same stuff for the Mac, and, whoops, sorry, we'll have him run through how to do this stuff for the Mac. So Marcus, do you have your get opt long already done? Oh, your get opt, so your get mode. So get your get mode up to where I am, and then you can just do one of the other things. Okay, but we'll get to that in just a few minutes. So now what happened here when I ran it was I had to type the input by hand. And that's kind of a pain. So what we want to do is we want to say, hey, Visual Studio, don't make me type that input, read it from a file. Because when we uploaded our starter files, there were actually 2 sample files that came with it. So what I'm going to do is I'm going to go back to my right-click Project 0 and say Properties. And then my debugging command arguments, I'm going to add to this. -m resize, and then I'm going to say less than sample-r.txt. So there's 2 sample files, sample R and sample N. Sample N is used only with the no size argument. Sample R is used with resize and reserve modes. So I'm going to add that in. So it says read from the sample-r.txt, hit enter, say OK. And now when I run it, it looks like nothing happened. Here's a problem with Visual Studio, and I figured out what it is. It's redirect. Visual Studio, when you redirect, it likes to close the window without showing it to you. So what I'm going to do is I'm going to go back to main here, all the way down to the bottom of main, and I'm going to put a breakpoint on the return 0, and then I'm going to say debug, start debugging, and it'll be forced to let me see it before it's done. Okay, so it stops, it moves over, Alt-Tab back, and there is what we should see. Is we should see an average of 13.39 and a median of 12.7. And now it's waiting for me to start the debugger and let it continue running, and it'll close the window. So if you've got everything right and it displays that, awesome. If not, it's not your fault probably. We got some work to do with getting you used to using the redirection and stuff, and the get opt long and stuff like that. So let's see. So I'm going to stop here. So let's say finish that. Okay. So I'm going to stop here and let Professor Darden show you how to do this stuff inside of Xcode. And the microphone there seems to work fine.
Yeah, seems good. I wander a bit.
Okay.
Where did that section go? Audio control, there it is. All right, coming back. I have to reconnect my screen. Yeah. Shoot. Say that one more time. VS Code, what about it? That's awesome. Yeah, we'll do some VS Code in a second. VS Code's totally fine.
It's just, I've been using Visual Studio for
Long time.
16 years, I think. So I'm used to Visual Studio. I didn't ever switch to code.
I've been using VS Code lately myself, so I had to dust off my Xcode skills just to get it to work. I did. Let's try that again. I know I just typed it in, it just didn't do anything. Hold on a second. We're arguing about what exists and what doesn't exist. That's not going to work. That needs to release. Okay, there we go. It has released. Now I can come back in with a 3823. Almost. All right, I'm having some Apple TV wireless problems here. It's time to go dongle. Always have a backup. There we go. It's right here, I get it. All right, and this is the one you used to, okay. All right. So, we talked about this just a few minutes ago. Visual Studio has problems with getOpt, and just about every other IDE has problems with redirection. Xcode, being no different here, has a problem with redirection. So here's a project that we have that's got a source file in it that you should grab. It's called Xcode Redirect. You see it there. Well, this is a new GitLab server. This is gitlab.umich.edu/eex281/Xcode Redirect. You see it there. This is for everyone that's not using Visual Studio. Even if you're using Eclipse or NetBeans, or if you're using some other IDE, you're going to have to get this thing here. If you're using VS Code, you don't need it. No, because VS Code just uses the actual command line. Yep. So here's the project again. It's Xcode Redirect. The file you need is this file here, Xcode Redirect.hpp. And if I go and download that file, Xcode Redirect.hpp, it tells me I already have a copy, which is fine. I'm going to overwrite that. All right, so I've got Xcode Redirect.hpp. I downloaded that. Once again, that address is gitlab.umich.edu, EECS 281, project name is Xcode Redirect. So that's it. Go there, download the thing. Now I'm going to hop back into my Xcode project, and I have to add that to my project, which I will do again, add files. It's going to give me copy if needed. I go to downloads. There's Xcode Redirect. All right, I've got a new file here. It's Xcode Redirect.hpp. What I need to do is put that in here. Just like that. So if you've got a Mac and you want to do your arguments with your input redirect, you need this to make your life work inside of Xcode. Without this, everything will work just fine. Even with it, it will work just fine on the Autograder. But for good development cycles on your Xcode, you need that there. And then right here, after you do this iOS base sync with Studio faults, you need to call this function Xcode Redirect with argc and argv. Just like that. 2 lines to add there. This line needs to be added inside of your main. Put that in there before you do any argument handling, before your call to get mode or any sort of messing around with getopt. Xcode Redirect, and you just pass it argc and argv, and then magic things happen, right? So here is include Xcode Redirect.hpp, and from there, it's got a function declared in there that you need to call. Xcode Redirect.
In the files resources, I just added an Xcode Redirect.txt with a link in it.
Excellent. I thought that was in there already. Huh, okay. So you can find this in files resources. There's a link in there under the Xcode Redirect.hpp file. Good. Questions? Did I leave anyone on this one? You're good? Shoot.
And so we don't have to do anything with get OBT like.
You still have to do getopt. You still have to do all the getopt stuff. It's just that when you set it up like he showed in Visual Studio, where you say, I want it to redirect from this particular file, that won't work in Xcode unless you put this in there. Yeah. Yep, there's a shorter shortcut than that. Let's go back here to Canvas. Under Files, it's in Resources. And if you look in Resources, not in Resources. Oh, under Xcode Files. If you go here is the Xcode Redirect.hpp. You click on that, it will give you a file that has the actual link to it. Because Canvas doesn't allow us to put links. It lets us put files with links in them. There you go. There's where the actual project is. You can go there and find that. So there's the link you're talking about. It's good? I can't make it any bigger. It just gets... All right. So that should get you Xcode Redirect. And the 2 things that I have to do to use Xcode Redirect again, I need to include it at the top of the file, somewhere near the top. And then I also need to call that Xcode Redirect function inside of main. Now, Xcode Redirect is a function that tries to mimic shell behavior. So what happens is if you run this program in a normal shell, the shell overrides this. So you can just leave this in there. It will work fine on the Autograder. It will work fine on Kane. And it will be giving you the chance to debug here inside Xcode. All right? I think that's where I'm supposed to pick up. Shoot. Yeah, that's what I'm going to get to right here next, right? So I think I've already gotten My options working right there, right? I've got help in mode. I've got HM colon here in my get opt line. And every time you write a to-do, you should clear the to-do. There we go. After that, I've got read with resize. We already did that one, right?
Yep, or did resize.
And we did read with reserve.
No, we didn't do reserve.
There it is, right? It says I've got to do these three things. First, I have to read in the size, just as I had done before, into a size T. So I did that, and now instead of resizing, since this is read with reserve, I'm going to call reserve, which you see there in line 101. Data.reserve size. And this uses the vector in a way that tells it we need memory. That's what reserve does. It goes and gets that memory. But it doesn't initialize the memory, and it doesn't actually have me using the memory necessarily. So when I start out here with a brand new vector, and I say reserve 100, there's two important properties that the vector has. One of them is size, which is how much data is in the vector. And the other one is capacity, which is how much data can be in the vector. So reserve changes the capacity without changing the size. So in this case, I've got an empty vector. It's got 0 things in it. I say reserve me 100 things. It says, great, now your capacity is 100, but your size is still 0. So I read it in. I use data.reserve, that's step 2. Set the maximum size of the vector. Now when I go through this for loop, I can read in each value that I want and use push back. I can always use push back, even without reserving. But anytime you know ahead of time how much memory you're going to read, you should always set your buffer to be that size. And here, since I knew I was going to get some number of elements named size, I set it to be that size, and this pushback function then starts putting them in there. So when I start out, size 0, capacity 100, I push back the first thing, it puts it at position 0, index 0. Then I push back the next thing and push back the next thing and so on. So what I'm doing with pushback is I'm increasing the size. In a vector, if you ever push back and your size and capacity are equal, the vector goes and gets more capacity and then puts it in there. So here, since I know ahead of time how much capacity I'm going to need in the end, I can get it once, and then every time I push back, it adds something into that capacity that I've already declared, or sorry, I've already allocated, reserved it. Does that make sense? It's pretty similar to the function above there. The function above there, though, when we say resize, resize moves both capacity and size at the same time. So I say resize, it's going to give me a size of 100 and a capacity of 100. So that's why you can square brackets things into a resized vector, but I need to do a push back into a reserved vector. Because the reserved holds the memory for me without initializing it. Push back initializes that memory and puts something in there and tells the vector to grow its size. That's good so far? Shoot. Depending on what you know, right? Depending on what you know and what you have. So in this case, I'm just putting in doubles, and doubles are built-in types. There's no problem there. But if I've got some other object, say I've got a zombie object, and the zombie object needs parameters before I can construct one, if I were to call resize, it's going to go create me 100, default constructed zombies, which I may or may not be able to do, right? Like some objects don't come with a default constructor. So I say default construct me 100 of these things that don't have a default constructor, the vector is going to fail at resize. But if I reserve the memory and then place them back into there, it's going to be able to create them at that time and do that like that. Yeah, if like for instance, if you're going to initialize something to a bunch of default values, then Resize works just fine, right? If I'm going to be reading things in, it makes no sense to go create those objects twice. So you would use reserve, right? The unused reserved memory, it just sits there. Same thing happens in a vector when you've got, it happens at any time when size and capacity aren't the same, you just have extra memory that's not being used, right? So if you do a bunch of pushbacks and you fill up to size and you push back one more time, the vector goes and gets double the capacity and it just sits there with most of that stuff empty as well. So that's how it works. All right, I think I haven't been compiling as I've been going here, but if I hit a Command B, it builds. So I'm doing good here. Now I need to figure out how to get those data values in here. I've got these couple of files here, sample N, sample R, and since I'm going to be doing a sample R, right? What I'm going to do here is find out where that file actually lives. That's kind of an important thing. So once again, I pull that drawer over there from the right. You see it gives me file information. So I'm going to go select my input file over here, sample-R, and then you see right there, I get a full path for this entire thing. And this is just the easiest way to do it. I just go over here and drag a copy of this beast right there. Just Command-C, now I've got a copy of it. So when it comes time to changing these arguments, I need to go into this thing that's Edit Scheme, and you can get to it here right by clicking on this Project tab right there. The other way that you can get to it is if you can go into Product, Scheme, Edit Scheme, or just Command less than. All of those will get you into, no, not you, Command less than, we'll pull that up. Here's where I get to edit those arguments. And you can put as many things as you want in here, and they sort of give you these check boxes so you can turn them on and off, and I'll see a lot of people doing this during development. In the Visual Studio version, you've got just the one field. Here you can build this up and say, well, what if I want to be testing my dash mode resize? That's something I might test. Or I might also test that as dash dash mode resize, right? Or I could add another one, which I might call dash M reserve. So I can put a bunch of those in there, and of course, I only want one of them at a time, so I can uncheck box those things. So now I've got reserve getting ready to happen. I still need to get some input though. And what that input is going to be is, move above there. There we go. It doesn't matter what order it goes in, but I just like it down there. I'm going to say less than, and this is kind of important because people with Macs like to sometimes put spaces in their file names and folder names, and that's unholy. So just make sure you put some quotes right there. So you see I've gone less than, open quote, close quote right there. And then all I'm going to do is back up in between them and hit Command V, which pastes that full path in there. Because if you don't paste the full path in there, chances are you won't get it to work. There are some other ways to make it work without that full path. But there you can see I've got the full absolute path to that file. So you can see when I run this, it's going to be dash M reserve with a less than of the sample r.txt. Yeah. Questions on this? Is it good? You're with me? Yes.
Really big common mistake is not having a space.
Yeah, the new file fixes that too, though. Yes, so there was a mistake here. If you do have some weird stuff, there was an old version of this file. If you got an old version and you don't have this space there, weird things happen. The new hotness has fixed that, but just make sure you've got it in there if you need to. Yes, I did this open from either Project Zero Edit Scheme, that got me there. I can also go to Product Scheme, Edit Scheme, or I can also just do Command less than. They all get me there. And I want to be on the Run for debug, checking my Arguments tab there. That should get you there. You see where I am? I'm on this one, and this is blue. It's a little hard to see at this magnification, but If you get here, you might not see what you're looking for. You need to be on arguments. Yeah. I went over to that drawer on the right. I just dragged the text right there where it says full path. I dragged that and did a copy with my keyboard. All right, so once I close that, I should be able to just run it. It builds, gives me an average, gives me a median. Life is good. Which arguments? You would have to go to a terminal to do that. To do it with like the run button from inside of Xcode, that's not going to be a thing, I don't think. You can, if you wanted to, you could combine these things. So I could have something that looked kind of like this. I could see like dash dash mode resize redirected from that thing like that, and then I could turn these things off. So I could do that all in one line. Is that what you're talking about, or just you're talking about being able to do it at the command line? This is replacing your ability to command line, because all I can do to make this happen is, once I do this, is I'm really just hitting this run button right here. I'm hitting that. It does a build, and there it's running it like that. Anybody get stuck on that one? Yeah. All right. We're rounding this one out. I got one last function to write for you, and we'll write this one together. Get back to project0.cpp, and if you're using your Xcode here, or Visual Studio, yep. Right, I like to get these to-dos out of the place. We got that get mode done right, so I'll take that out. Add a project identifier, still haven't done that. But here's the last function I need to write. This is read with no size. And this one is critical because oftentimes people get taught improperly how to read things from a file when you don't know the size. The first two are easy because the first field in there was the number of things that followed. You read that number, and then you read that number of things. When you don't know how many things that you're trying to read, you need to control yourself by letting the input conversion fail when you should stop, and realizing when the input conversion fails and then stopping, right? So here I am at read with no size. That's what that other file sample-n is. It's just data. I don't even know how many things are in there. So I'm going to write this function. It should do the following. Use a while loop to read in the values, storing them into the vector using data.pushback. Now this is a situation where ahead of time, I do not know how much memory I'm going to need. So I can't reserve, I can't resize. There's no sense trying to fix that. Unless you've got ballpark numbers, you might get some help out of that, but then it could still make things be horribly wrong. Being as efficient as you can is to just read and do pushback. It will cause the vector to grow and double and grow and double and grow and double, but there's nothing you can do when you don't know. When you don't know, you leave it how it is. So all I have to do is read in a data value and push it back. Whenever I fail at reading in a data value, then I should stop. So I'm going to need a value to read this into. So for starters, I'm going to do exactly what this says, delete all of this. This just helps me compile. So I'm going to say double, and I call that thing value. And then I'm going to put the while loop it asks for in there. Done. Ah, that was quick. Did you look down? All right. So what's going on here is I declared a value as a double, so I can read information into that. Then I use my while loop with the terminating condition being, when does cin fail? Because if I can read from cin into value and again get converted into a double, It works. I get true-ish out of that, so my while loop continues. So since I got something true-ish in the while, I go inside, which is where I push that back into the data, and that's really all I needed to do. As soon as that's done, the loop is done, and I can go back and try reading it in again. Does that make sense? So if you do some of the common mistakes, while cin.good or while not cin.fail or while anything, right? What's another one? While not cin.eof. Every single one of those can lead you into a problem, especially with files that might have empty blank lines at the end of it. You'll start reading things in and generating garbage data, and it won't be good. So using this, I say, as long as I can get a valid value from the file or from the input, doesn't really matter whether it's a file or not. As long as I can get valid data from the input, grab that data and put it into the vector. All right, so let's see if this builds. Okay, that worked. That wasn't surprising, right? And all I did here was went to product build, or I did command B is what I did. It builds, and now that this function is written, I can knock that to do out. But what I need to do is change my scheme so that I can have one that does one with no size, right? And so I'll add a dash mode no size is the name of it, and I'm going to redirect there from sample-n. And I got pretty cheap there. I just pasted the old R in there and edited it. For your purposes, though, you can go grab this thing right here, look at the sample-n file, copy the full path just like that. I copy it out, command less than, and paste it into here. So you see how, while you're doing your development, you build up a whole bunch of these little command line combinations that you might want to try, and you can have them separate for every argument. But it's important to test both sides of these things, because the Autograder does. By both sides, I mean -m, the short version, and --mode, the long version. A lot of times that's where you can write a single character error that will take 20% or more of your project and turn it into zeros, because the Autograder doesn't read that option well and you don't realize it. So make sure you test it yourself before you push up. So there you go. I've got mode, no size, sample n as my redirection, and when I run that, the build succeeds. I get that average 13.39, the median 12.70. So you can see here's a sample R file with the leading number of items in this file, and the sample n file with that removed. But the important part there is to be able to read when you don't know how much information you're going to get. Say that again? Oh, if we had both of those, that's a weird input combination. If you've got a double redirect in, you're saying? I don't know what happens when you override less than. Like less than file A, less than file B. I think that's an error. However, Xcode Redirect might not error properly on that, so just don't do it, because it's not valid in general. Never tried it. Oh, I'm still not hearing that. Oh, that's just one of our styles in 281, right? We've got closing curly braces there just to let you know why they're closed, right? That's what you're talking about, that comment in line 117?
Yes.
Yeah, that's just a comment. It's really not that important on a function that's 4 lines long, but when you get a function that's pages long, you know what I mean? And especially if you're inside a class and you can see something that's closing a function, you want to make sure that you're looking at the one that you think you're closing. It's just the documentation thing. Just like I do like my while loops there, like that comment in line 116. I'd do something like that to know this is the end of a while, this is the end of the nested if, or the nested if, and so on. Things like that so that I can see them visually. It's a totally style thing. Any questions on this? Any questions on Xcode Redirect? We see how it works? Okay, pretty good. You are either all set or just tired of hearing us talk. Either one of which is fine. I'm tired of talking. Make full submit? Let's do that. All right. So the Autograder would like for you to have what's known as a tarball. A tarball is when you take a directory or a collection of files and you get them ready for archiving, which is the tar function. Tape archive, that's what it stands for. It takes a bunch of files and turns that into one file. And then you can take that file and compress it, and that's what TGZ stands for, tar.gzip file. So I've got a way to do that over here in my command line. All right, let's see what's going on here. You can go away. All of you go away. All right, so much distraction. All right, so here I am in the Project 0 file. You can see that I'm here with the stuff. I've got the Makefile, so I can do, I need a project identifier, I do. Anybody have that handy? I can copy from a PDF, fail. Rum-bum-bum. Okay, there it is. Do, 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 do. Sorry, I got to get a project identifier. Sure. All right, so what I'm looking for is there, right? Nope, it's not there. There it is. I need this string right here. That's my project identifier. That needs to be in a couple of places. It needs to be in the Makefile, and then it needs to be in any source or header file that you write, that you include. So I've got to put this in my Makefile, and I've got to put this in project0.cpp. Right? So I've copied it here in text. I'll jump back into Xcode and get over to my last to-do. Add project identifier. There we go. I'll say project identifier and that thing. That's good enough. And I'm going to save that. And then I jump over to the Makefile, do the same thing. Remember in our to-dos, I have to replace this. Aha, now I'm good. You followed me on that one. You were already ahead of me, I think. The Makefile won't come with anything else. There's no starter files after this. So the project identifier will always be in the spec document. No, the spec is like the PDF file that we show you that's all the description of the file. And in there is going to be that. You need to put that into both your Makefile and your source code files. Yep. So I've got it in both places now. I should be able to jump over to my command line which is where I was here, and I should be able to type something like make. Look at that, it compiles. I can also do some stuff from here. I could say .project0-m resize redirected from sample R. All right. So I see that it works. This is something you want to test before you bother sending it to the Autograder. If you are working on Windows, you would have to do this from inside your WSL to make this work really nicely, right? We'll show you that. Or if you want to push these files up to Kane, you can do this very well from there as well. But what I need to do is type a make full submit. And you see it tells me what's going on there. When I type make full submit, it first removes any old submit files that already existed. You see that rm-f partial submit.tar.gz and full submit.tar.gz. So all the old submits are deleted, regardless of whether they're partial or full. Then it creates the tarball in this next line with copy file disable. You see it tar minus vczf into full submit.tar.gz. It adds Makefile, it adds Xcode Redirect, it adds project0.cpp, and then I now have a file in my directory named fullsubmit.tar.gz. That's the file I'm going to put up on the Autograder. You with me? Let's do it. Hop over to the Autograder. And what's my name? There we go. Project 0. Choose a file. I'm going to get back to where I was. That was in my development directory. umdev, EECS 281dev, winter 20 dev, project 0, and there's my full submit.tar.gz file. All right? Check the timestamp. That's Dr. P's favorite thing to say about this. Check the timestamp. It says 407 on there. It's 409 and a half right now. This is probably the one I just made. This keeps me safe, though. Checking that is looking good. So from there, I'm going to select that. That's what we call a tarball, this tar.gz file. You see that it now fills in full submit.tar.gz. The name on this file doesn't matter as long as it's a tarball. When we download it on the Autograder, we give it a separate name. Don't worry about what you name it. Call it what you like. The Makefile calls it full submit by default. All I have to do then is hit upload here. And you see that I'm not alone. All of you are running your files. I'm right there at the top. And there's my output, right? So this is what we get from output from the Autograder. Staff lovingly calls this file run out because it's got the name run out. So you'll see some things at the beginning here. There's some legalese type stuff. Keep in mind, the Autograder does not assign grades, blah, 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 blah. The lawyers put this in there. No, they didn't. We did. But it's legalese, right? After that, it's looking for things that don't belong. All right? Anything that shouldn't be there complains about. Then it does a static analysis to check for style errors that are warning level or error level style errors. CPP check is the static analysis tool that we have. If you would like to do this yourself, you can, at the command line, you can say something like make static, and it'll run that same static analysis that the Autograder is running. So if you want to know how to figure out what that's doing, you can do it right here. While I'm here, Dr. P says I can also type make help. Make help gives you all the information about this particular make file. That's not a general thing, it's just the way this make file works. So you can't always type make help. You can just type make help in this directory. All right? With our make file. So there we go. There's static analysis. After that, there's another style checker that goes in. It's much older. It's less important, but the information is still being included for historical purposes. We could turn it off. We have not yet. After that, it looks at what's going on in my files. I got a project0.cpp. It's an ASCII C++ program text file. tells me that I've got some problems with lines that are too long and inconsistent brace styles. These are just style complaints. They have not changed what's going to go on there. Then it complains about Xcode Redirect. It says there's lines with 80 characters. Let's complain about that. All right. All expected files found. Then it goes through and does what Make did. Right? Make did a G++ on project 0, which gave me project 0.0. Then it did a G++ on project 0.0 to give me an output called project 0. If you don't check this section, errors that happen during your build here will go on, and I have seen people that have spent days submitting to the Autograder and getting nothing back and nothing back and nothing back because it says right here, hey, we can't find your executable. It's supposed to be named project 0. And they didn't change that line from executable in their Makefile, so when they build it, their executable is named executable. It's not named project 0. The Autograder don't know. So you have to edit that and check this section because if anything goes wrong, here's where you find out about it. After that, we're just going to run a bunch of tests. And you can see what each test looks like. We got each one of these test cases, and they're sort of separated by these dashed lines. It will tell you information about that particular test case invocation. Tells me test case SV. If you look at the spec, it will tell you what the legend for these test case names are. They'll tell you whether it's a large data set or a small data set or a medium data set, or if it uses queues or stacks, or if it's going to go in reverse order, or whatever it means for that project. If you look at the legend at the back of the project, it will tell you what this 2, 3, 4, 7-digit code tells you about the test, which is very important when you're trying to fix what's wrong. It's like, I got all of these blue lines, I got all of these green lines, and I got all these red lines as I keep making submits in the Autograder. So every time I've got a red line, it's because I'm using the queue. Everything else passes. Maybe there's a problem with how I'm implementing the queue. Go look at that. So that's what's very important about those things. Then it tells you what the runtime of that test was in line 51 there. Runtime in seconds was 0.002 seconds. Very fast test. However, the budget I had on that test was 0.004 seconds. So anything faster than 0.004 is going to give me full credit. Anything slower than 0.004 is going to start giving me discounted credit. So here I've used enough time to be good. The same thing with memory there. I've got memory at 1,600 kilobytes, under the 2,000 as my budget. So that's going to be good as long as my answer is good. So that's why you see in line 53, I earned 1 point out of 1 point available. Now, had I gone slower, I might have earned 60% of that point or 50% of that point, depending on how slow I got. The slower I get or the more memory I use, the more discounted my score is going to be. So you can see all of the test cases. In this case, I passed all of them. You can go back and see whenever you have a problem with any of your test cases, you would see it here. I get down to the bottom, I've got a summary. It says I passed 9 out of 9 test cases, earning me 8.90 out of 9.00 points. I got a discount, 2 discounts.
It's probably because there were 12 people on the Autograder.
There were a lot of people on the Autograder. So here you can see that my runtime got discounted because I took too long. Quite a bit too long, right? Exceeded by a factor of 1.272. So this one gave me a 5% off on my score. I think that was because there was 100 people on the Autograder at the time. So you can kind of balance that out. What's the queue look like right now? I still only got 1 person in there. I might try resubmitting that one. But then you'll all do it too, and I'll just be slow. But that's how you read it, right? So it'll tell you all the things. You get your summaries down there at the bottom. In the normal projects, there's also a situation where we check for memory leaks. And there's going to be a section here that says you passed your memory leak check. It's plus 10 points or whatever. And then there's the final summary line that said I got 8.9 for code. I had no test files. That'd give me another 10 on a regular project. And 10 more points for memory checking, which this project doesn't do.
So on real projects, that kind of discount happens for like you touch time because will it like redo it?
No, doesn't redo it. But before we take your actual grade, we will redo it.
Oh,
right? And we end up redoing it in a way where we shut the Autograder down and we only let one project go at a time. Right now, this is an 8-core machine, and we're running 6 cores on people submitting all at the same time. But there's still only one hard drive, there's still only one database, and all of those things have to be used by the multiple solutions that are being executed. So during practice time, you will get some interference from other people. It's not major, you know what I mean? And it's usually not that bad until you get to the 5 minutes before 12 on the due date. It can be kind of hairy there, so don't have that be your good submits. We will still run it fully all by itself, though, even if that's the case. And then there's still a chance for some minor time discrepancies. We go back and review all of those time discrepancies as well. I got one down here, and then you in a minute. No. No style penalties.
Okay, so if I have a test that's like slightly over time, trying to fix it, for hours, and still not getting it, it's possible that I'm doing everything right, and when you run it by yourself, it's actually going to be under the budget of the time. It's going to work.
Yeah, it's possible because I'm solo right now. Ha! Look at that. Nobody's in the queue. It's just me. I'm in. Nobody's hitting the database. I'm out. Wow. Those got better. Something else got worse, right?
And the thing is, this is not something we can control.
Yeah.
We told the operating system, run this program, tell us how long it took. That's the number it gave us.
It's the real deal. So, and it's just part of measurement. That's the way that measuring execution time on computers works. So you saw the test that I got 100 points for last time. I got 95 on this time. The other two that I got 95s on, I got 100 for. So back to project here. Oh, yeah. So here's my summary. And you can see this is the other view that you'll get when you get to the Autograder. You can see the tests that I passed. Anything green or blue is a passed test. Green tests are passed with full credit. Blue tests are passed with discounted credit. Red are not passed tests.
One last question.
Yeah.
If on one of my attempts, I have a test that went under time,
Yeah. It's mostly. I mean, here you saw me running that first one under time. I was at 0.002 the first time. The second time was 0.005. So it's not a guaranteed thing, but it's not going to be done unfairly to you or to anyone. So, yeah, so that's the best we can do. That's the best we can do. Yep. If we have real problems with any particular test case because of something that's gone on in software updates or hardware updates, then we may go back and ease the requirements on it. But like I said, we're not going to be unfair to anybody. So that's what we're trying to do. Yeah, the question was how to deal with performance time testing on your own machine. It's going to be a different clock. It's going to be a different execution speed. Everything is going to be different. But what you can do is say, well, if this is 40% too slow on the Autograder, and I just made some updates and it's only 10% faster on my machine, it's probably not going to be 40% faster on the Autograder either, right? So it can be relative that way when you're trying to fix a problem, but there's no direct correlation between all of the different processors and all of the different hard drives and all of the things that we can actually give you. So what you can do is just do your local testing, time it, and we'll talk about this in class. Do your local testing, time it, then make your edits. If the timing hasn't gotten any better, it's probably not going to get better on the Autograder either. So, all right. I think that does it for the presentation.